Hello, everybody. My name is Daniel Maevsky. I'm responsible for the general architecture of the system, a good chunk of the gateway and authentication microservices, and most of the client side. A quick note before we start is that our most significant achievement since the last demo has been the creation of our front end, though we did implement some new system functionalities as well. To start us off, I would like to go over the general idea behind our project, FitBud, and talk about the system architecture. FitBud is an application for tracking your fitness. It can log your meals and exercise to make sure that you stay on track with your weight loss and weight gain goals. We offer an extensive database consisting of nearly 400,000 foods and an exercise database that is sure to have what you are looking for. Now, I want to turn our attention to the architecture of our system. For this project, we decided to go with a microservices-based architecture. In such an architecture, there is a master coordinator called the API gateway, which makes calls to individual system modules. The purpose of this gateway is to enable extensive modularity in our system and to provide the client side one API endpoint to manage instead of many different API endpoints. These modules, called microservices, are split up almost exactly by use case and are responsible for providing their own standalone APIs and interacting with their own independent data collections. Our system has three main microservices: authentication, fitness, and profile. The authentication microservice is responsible for handling account creation, user authentication, account configuration, such as changing password, and other, often cryptographic authentication related functions. We achieve this by deploying an OAuth compliant JSON Web Token authentication schema, which allows us to provide stateless authentication, increasing the responsiveness and reducing the system load that our backend needs to endure. The fitness microservice is the sole repository of everything related to fitness and is a huge part of the functionality of our application. It manages our vast database of foods and exercises. The fitness API gives our system the ability to search, create, and modify resources pertaining to the creation of many different fitness elements and collections like recipes and workouts that we have made ourselves. The profile microservice is responsible for handling the user-related data collections that we keep, from our users themselves to the resources that they generate. It is responsible for storing users, storing user diaries, providing user analytics whenever they may request it, and managing users' profile pictures through its interactions with Amazon S3. To begin showcasing our features, I want to demonstrate account creation and payment processing through our interface with PayPal. Going through the steps of account creation is very simple. You input your email, a password, and a number of physical characteristics to allow us to accurately gauge the different aspects of your fitness. Many of our calculations depend on this information, such as your weight, your height, and even your percent body fat if you know it. Upon completing this form, we are presented with a summary and prompt for payment processing. Our application interfaces with PayPal to allow users to register. Here we have a Sandbox PayPal customer account to demonstrate this functionality. The account creation process is managed by the gateway, which makes calls to both the authentication microservice and to the profile microservice. As you can see, upon successful payment, the user is automatically logged in and brought to their dashboard. Here, they can see their total calories eaten for the day, the calories burned, and whatever is remaining. This client-side interface is a great representation of the diary objects handled by the profile microservice. The JSON Web Token created by successfully logging in can be seen by examining local storage. On our client side, the existence of these tokens is what determines your status as logged in or not, and determines the many different features that you have access to on the site. We can also see some other resources provided by our backend that enable the successful operation of our app, such as the profile object and the current diary object. I want to also demonstrate the process of logging in, which makes calls to the gateway with an email and password. If correct, the gateway will respond with an access token and a refresh token, all part of our authentication schema. The final authentication-related user-facing feature is Forgot Password. If a user should forget their password, we have implemented a mailing system that will create a unique URL for them to use that gives them permission to change their password. This URL is valid for 15 minutes before automatically expiring. From here, I want to pass it off to Patrick Vega, head of profile and another contributor to authentication.
Hello everybody, I am Patrick Vega, responsible for the Profile and Authentication microservice. The authentication service was responsible for anything account related, payment processing, and authentication. The Profile microservice includes profiles and diaries. Once the account is created, users can view their profile and make changes at any time. As you saw during the account creation, many optional fields are provided that can boost the user's experience using our web application. Here, users can view all the information they provided and make changes that will reflect all over the application. For example, we can change the activity level, mess around with the macronutrient breakdown, change our weight, and save these changes. When viewing the dashboard, we now see the calculated calorie and macronutrient goals are updated. We can also play around with unit preferences and see it update live to match the preference. 3 inches and 250 pounds turns into 185 centimeters and 97.7 kilograms. Present on the profile page is the meal names, which will be explored more in depth during the discussion of the diary section. The feature present on the profile page is the profile pictures. We opted for a different NoSQL database that is better suited for dealing with file uploads. This is where we turn to Amazon S3 and its buckets. Amazon S3 is an object storage service that stores data as objects in containers called buckets. Each object will have a key, which must be a unique identifier associated with the object. Access and control of these buckets are private and can be configured with various policies that suit our needs. In this case, we want the bucket access to be very restrictive, only allowing our API to make calls and the root user to overview the bucket if something is wrong. We rename the images when storing to be the user ID of the user to ensure each picture has a unique identifier and will accidentally overwrite someone else's image. This is also helpful as editing the profile picture just means uploading a new image with the same user ID, which will just overwrite the old image with the new one. We see that until a picture is provided, we display the initial of your first name. We can now upload an image and see it displayed. Now we can update it and watch it display the new image. S3 reflects that a change was made on the same document in the bucket, that being our updated image in the profile.
Hi, I'm Malav, and I'm the team lead for the Fitness microservice. Here we deal with foods, recipes, exercises, and workouts. This microservice is unique in the sense that you do not need to register to use its core functionality, searching. Navigating to the food page, we see that we can search by keyword or by barcode. Let's try searching for the keyword vegan pizza. We see that we quickly get the results that best match the query. Let's click the top result. Here, we can see all the nutritional information as well as calculate different proportions. We have also implemented fuzzy searching, so even if we misspell pizza with one Z, we still get the best results up top. Same as before. We see a nearly identical use case in the exercise tab. Now, let's log in. Once again, navigating to the food tab, we see that we are now greeted with a few more options. The main search works just the same as for an unregistered user. However, a registered user can create a food and submit it to our database. First, let's inspect the My Foods options. Here we can see all the foods the user has already submitted to the database. Now, let's try creating our own food. Let's give it a name, and we'll call it pizza, and the brand is Costco. We're going to ignore the barcode for now because we don't have it. Now let's add the serving quantity metric. Let's say it's 150 grams. The serving name will be 1 slice. Now let's enter the major macros. Let's say 1 slice has 60 calories. 60 calories, 15 carbs, 20 grams of fat, and 10 grams of protein. Next, we see these sequence of fields that are optional. They are for additional nutritional content if you would like to enter. Let's scroll all the way down and press Create Food. Here, we see we are immediately directed to the New Foods page. This is slightly different from the unregistered user, as there's a few more options. For example, we can choose the meal and add it to the diary. This will be discussed more in depth later. For now, let's head back to the food page. Now, if we go to My Foods, we are now greeted with our new additional Costco pizza. If we go back to it, this is the same one as before, serving size 150 grams. The last major use case for this microservice is building recipes and workouts, which are groups of foods and exercises, respectively. Let's build a recipe. On this page, we see a familiar search tab on the left. We can search for foods, modify the number of servings, and then add them to our recipe. Let's add a bag of Skittles to our recipe. Let's pick the first one and add the food. Now, let's add a bag of chips. Let's go with the third choice. 1 serving, add. Lastly, let's add a bag of pretzels. Let's go with these pretzels and add 2 servings. On the right side, we can give the recipe a name and choose the number of servings. Let's call our recipe Gas Station Trip. We will keep the number of servings as 1. Here we can see an overview of all the foods in our recipe. Let's choose to delete pretzels. We didn't actually get those in our meal. Now we can press Save Recipe, which will send this recipe to our database. Let's head over there and refresh and check. As can be seen, here is our gas station trip recipe. If we further inspect the ingredients, we can see that the recipe does not store the food objects themselves, but rather the object IDs of each food. If we want to display the recipe, we can query by these IDs and get the food objects as needed. Furthermore, a recipe also stores the major macros. These are the culmination of all the major macros from each food item in the recipe. Workout Builder functions identically, but with exercises.
To build off of what was previously discussed in the fitness microservice, users can log daily meals and exercises in what we call diaries. Diaries are collections of various meals and exercises called logs, limited to 30 a day. Upon each day, a new diary is presented on the dashboard, as that will be where a user can track their dietary goals compared to what they are logging as far as meals and exercises. A meal log can consist of a food in the database or recipe you've created consisting of a combination of foods, making it convenient for logging purposes. An exercise log can either be a cardio or strength-related exercise from our fitness database, both offering options to specify what was done in said exercise. Here we can play with adding a few foods and exercises to simulate a user logging throughout a day. On top of simply adding logs, users can also edit what the logs contain itself, delete the log itself, and continue to add logs up to the max of 30 logs per day. Here we can start editing the logs we have provided and delete a few and watch the diary reflect all these changes. Diaries are not limited to the current day, but can be created and edited from previous days. And show here, go to the 25th, still make changes. On a previous day. If you miss a day of logging but would like to provide the meals still and exercise for that day, you can do so, and the same rules apply as the current log. As mentioned previously, the meal names in the profile control how many meal options appear for each diary and allow for customizing names that may better suit a user's need. Now we can head to the profile, get rid of one of these, change these names. Save these changes. And now go back to the diary, and now we see that these names are changed, and there's one less log available since we got rid of that last name. The logs are by default set to breakfast, lunch, dinner, and snacks, but can be turned into up to any 6 meals the user desires. The last thing available is user analytics / progress, displaying a trend of users' weight and body fat percentages throughout available diaries. This box located down here. You need at least 30 diaries created to display any progress, and as we've only created one diary, we will not see a trend in our progress. With that being said, we highly recommend and encourage you to make an account and try these features for yourselves on your journey of health and fitness.